Hi, it's Tom McDonald, and in this video exercise, what we'll do is create a class called Cartesian point, and we're going to manipulate that objects of that class in a console C# program. For those of you that have taken OOP 1 and or OOP 2 with me, will probably recognize the Cartesian point class as one of the examples that we used for basic classes in C++. So essentially what we're going to be doing in this exercise is taking what we already know about classes in C++ and just applying that in C#. So most of what we'll do will seem very familiar, although there are some notable differences. What I've done up to this point is created my console application in C#. I've named my solution as well as my project, my OOP overview. I've started off with a little bit of an opening comment, but I haven't really modified anything yet. You may want to pause the video and just get at least to this point, and then we'll continue. You can follow along as we go. The first task at hand is to actually add the Cartesian point class definition. I have a couple of options at this point. I can create the class in the same source code file as my class program with my main, or I can actually add a second C# source code file. I like to keep my classes in separate source code files. It just makes it a little bit easier to manage. So rather than just simply, make some room here and type in class Cartesian point, I'm going to do that. Okay, so an easy way to do that, I'm just going to make this a little bit wider, is on my project. Okay, I'm going to right click. I'm going to choose add and then class. I get a little dialog box and I got all these options. It's a class that I want. I want to give the class source code file a meaningful name, so I'm going to call it Cartesian point. Okay, then I click on add. Okay, so what it's done is it's created a new .cs file inside my project. It's basically a blank file. It's part of the same namespace, class Cartesian point, and everything's ready to go. First thing I'm going to do is I'm just going to put some documentation comments at the top. Okay, just before my class. So 1, 2, 3, there's my summary tag, and boom, there's my copy and paste. So the Cartesian point class represents a point on a 2D plane. It's designated by two integer coordinates, x and y. We're pretty familiar with what a Cartesian point is if you've taken courses with me before. Now, class Cartesian point, the way it's defined by default is what's known as an internal class. Okay, similar to if I actually said internal there. Okay, so you don't actually have to have the word internal, it's assumed. But what that basically means is that this class is available inside this particular project. Now, that's not what I want. I want to potentially be able to refer to the Cartesian point class outside, anywhere I want. So I can designate the class as, instead of our internal, as being public. So we understand the word public, in terms of inside the class, what it means. Basically putting it, the entire class as public just means that the class itself is accessible outside of the project. If I go back quickly to the program class, I can see that since it doesn't actually specify, the program class is really internal to this project. So that's a little bit of a subtle difference there. Okay, let's save everything there. So the next thing we want to do is set up the x and y attributes. Okay, so basically they're going to be variables to hold the x and y coordinate values. So first off, let's deal with the accessibility. I'm going to create a private field. Okay, so private, it's going to be an integer. I'm going to call it my x. So this is kind of the equivalent of a private data member in a C++ class. Now, normally in C++, what we did was we defined methods, typically an accessor and a mutator, to be able to get and set that particular field. In C#, what we typically do is we create a property. So let's do that. I'm going to say public. I want the property to be public. It's an integer property, and I'm going to call it just simply x. I'm not going to put a semicolon there. Rather, what I'm going to do is open up a compound statement, and I'm going to define what I want to do when I'm getting X. Okay, so getting X means that I want to return the myX field. Okay, and then setting X, what do I want to do? I want myX to be made equal to, and this is a keyword here, the value that I'm trying to set it to. Okay, and then I close that off, and I close off the body of the property. So this is how things are set up. Again, a private field, okay, and then a public property that's linked to that field. That's essentially defining how to get and set it. Now, the way I've set this up is actually a little bit not very useful, because I'm not adding any restrictions on the set or the get. Particularly in the set, I don't have any validation that I do on the value before I try to set it. So really what I could have done is avoided this altogether, and instead of doing that, simply made the field public. And if you make a field public, you should be using Pascal case, by the way. Now, rather than make the myX field public, what I'm going to do is I am going to add some validation. So I'm going to change the contents of my set block here. All right, so when I'm trying to set the X value before I actually change my X, and I've arbitrarily said it has to be between negative 100 and 100. We're going to modify this a little bit later on to make this more useful, but for now I've just set those minimum and maximum values arbitrarily. So if that's true, if it is in the valid domain, then I can go ahead and set my X to value like I did before. But otherwise, if it's not, then I want to, do some error handling. Now, the best way to handle this inside the class, because this could be in a GUI project or whatever, is to simply throw an exception and let the application programmer handle it. So I've decided to throw a new argument out of range exception, which is one of the standard exceptions in .NET. I'm passing it what property caused what property caused the problem, what the actual value was, and a little bit of a message there saying the X value must be assigned a value between plus or minus 100. Okay, so that's my new set, which makes this a little bit more encapsulated, right? I can't set my X outside of a particular domain. So let's tidy this up with a little bit of comments. I'll add a summary up at the top. I'll just label what my X and X actually are. And a couple of notes for myself about what the get and the set actually means. Okay, so this is the X attribute, including the private field that stores the value, as well as the kind of the methods we would need for getting and setting that particular attribute. I'm going to cheat a little bit and add the same thing for Y, since it's going to be essentially a replication of what I'm doing for X. I'm literally just going to do a copy and paste, and then of course go through and change all the X's to Y's. As I said, it's a bit cheap, but it works. All right, there we go. So we've got these two attributes, X and Y. They're instance attributes, meaning that each individual object will have its own version of X and Y properties, right? It'll store a my X and a my Y value that's different, could be at least potentially different than other objects of the class. The next type of attribute I'd like to create is a static one. So how we'll use the static here is in terms of this limit that we set on these attributes. So I arbitrarily set it to 100. What I'd like to do is I'd actually like to have a shared attribute in the Cartesian point class that actually defines what this limit is, so that all Cartesian points will be using that same limit. Okay, so I'm going to basically do the same thing here, but rather than it being an instance, it'll be a static property. Okay, I'm going to do that up front here. So similar to before, I've set up a field that was private. I've called it the limit. I'm not using my limit anymore. My kind of implies that it's an instance field. The is a little bit of a better name, I think, because it reminds me that this is going to be shared by all Cartesian point objects. The keyword static is important here to make sure that it actually is a shared field. I've initialized it to 100. This is kind of going to be the default. So if I don't actually go ahead and set it later on in my application, it'll be 100 right up until the point that it's set. And then publicly, I have a property called limit, which is also a static property. Get, as you would expect, just simply returns it set. There's no real need to do any validation here. I suppose what I could have done is made this a static public field, but at any rate, I didn't do it that way. So at least there's the potential later on to have some validation or other types of actions in the accessor and mutator for the limit. So now that I have that, I can go ahead and modify my validation to make use of limits. So this would be negative limit. Of course, I could say the limit there as well. That would also work. Limit. I like using the properties. And then of course I have to have it in here as well. Oops. Okay, and then I do the same thing for my y. All right, there we go. So that was implementing a static property. Next, I'd like to add a constructor for this class. Okay, it doesn't necessarily matter where I'll put it, but I like to, because it's a method, I'm going to do it, well, I'm just going to do it right after these properties. So where am I at here? Okay, right about here. So I'll add in my constructor. You don't need to watch me type it, but it's a public method. Okay, in this case, constructors normally are, but there are such things as private constructors. We'll talk about those a little bit later. It's just like in C++, the constructor is the same name as the class. In this case, I've got two parameters, one for the x coordinate and one for the y coordinate. I've defaulted each of those with default arguments to 0, just the same way we would in C++. I'm not using the base initialization method to initialize those two members. There is a base initialization list technique in C#, but it's not for members. Any rate, so in the body of my constructor, I want to set x and y, and I want to have all the proper validation. So I've already got the validation in the sets for the properties. So I'm going to use the property name x equals, and then the parameter name x, y equals the parameter name y. And if x and y are actually out of range, it's going to throw the exception, because recall that it's going to be using the set for the actual property. So this kind of simplifies things a little bit. We don't have to replicate any validation there. So that's my constructor for initializing instances of Cartesian point. I'm going to add another method that's very similar in concept, and it's just going to be initializing or setting the point, not initializing, but rather modifying an existing point. Okay, so you can see the actual bodies of these are exactly the same. The constructor is for when we're initializing the instance in the first place, and set point is a method we could use to set the x and the y at the same time. It's really just another method available to the programmer. Okay, the difference being when it's actually called. This is called explicitly when the programmer wants to change an existing coordinate. This one is called, it's also called explicitly typically in C#, but it's when we first create the object in the first place. Now in our original C++ class, we had a toString method, which allowed us to output the x and y coordinates in a formatted string, it returned a string. So we'll replicate that functionality in this class, but there's one kind of difference that you need to understand is that all classes in C# inherit from this very, very basic class called object. It happens automatically. You don't need to do anything to make that work. One of the methods in the object class is toString. So there's some default functionality built into every class converting to a string. So since we're defining our own toString and exactly what we want it to do, we're going to be using the keyword override. Okay, so we're overriding the toString method that's in the base class that we inherit. We haven't talked much about inheritance. That's going to be in the next tutorial. We'll get into that in a lot more detail. But it's just something that I'm pointing out for now. And it allows us to recognize too that there is this base class we're inheriting that you should be aware of. Okay, the function itself is relatively simple. In C++, I think I might have used a string stream to build this string. Here I'm using string.format, so just the .NET equivalent method to put the coordinate in terms of a open parentheses, the x value in fixed to 0 decimal places in this case, followed by a comma, the y value. Again, I'm using fixed to 0 decimal places. Pretty straightforward little thing there for converting a Cartesian point into a string. Another method that we had in our C++ version was it initially was a member function called to or get distance between or something along those lines. But it eventually became an overloaded operator. So let's overload the minus operator in this class to give us the distance between 2 points. Okay, so I've got some lengthy comments here. It's operator minus, calculates the distance between 2 points. I have 2 parameters in this case. The way that we did this in C++ is we made the operator a member of the class, which meant that the left-hand operand was kind of implied as being this object. Binary operator overloads in C# are a little bit different in that all operators have to be overloaded statically. Okay, which means that you have to define in the case of a binary operator both the left and the right operand. So you can read more about operator overloading. It's not well defined in the textbook, but in MSDN, and there's a link to it there. You can copy down if you need to. But at any rate, it's a public operator. It's static, okay, as operators need to be in C#. It returns a double. The distance between 2 Cartesian points can have a fraction. It's called operator minus. Okay, that sort of makes sense, the difference between 2 points. The left-hand operand I've just called point A, and the right-hand operand I've defined as point B. Okay, and then to determine, I've just used Pythagorean theorem there, a similar type of formula we've used before. Of course, I'm using the math class, the static method square root. I don't like squaring things with a function, so I'm doing the longhand, but essentially that's returning the distance between those 2 points. So I will do a save all, and that is essentially the Cartesian point class with a few little modifications that we created in OOP 1 and 2, implemented in C#. What we'll do in the next video is we'll go back to the program class in the main method and actually create a couple of objects and test things out.